Thank you for being here. My name is Associate Professor Dr. Woon Kai-Lin, and today I'd like to explore a very practical question with you. How can we use AI to turn challenging subjects, especially in STEM, into engaging, self-motivated learning experiences for our students? Let me start with a simple story. Imagine a 10th grade student. Let's call her Sarah. Sarah is sitting at her desk staring at her algebra homework. She's been stuck on the same question for 20 minutes. She's tried something, erased it, tried again, and now the page is half full of smudges and half full of frustration. What is she feeling? Maybe she's thinking, I'm just not a math person. Maybe she's thinking, even if I try, it won't make a difference. And after a while, she simply gives up. Now, imagine a different scenario. After class, Sarah has access to an AI tutor. She types in the question, and instead of just giving her the answer, the AI asks her what she's tried, gives a small hint, breaks the problem into smaller steps, checks her work instantly, and nudges her forward. The problem hasn't changed, the curriculum hasn't changed, but her experience of learning has changed completely. This is the core of our session today. Can AI help us reduce frustration, increase persistence, and grow intrinsic motivation without turning learning into copy-paste shortcuts? Before talking about AI, we need to be clear on two key concepts: engagement and intrinsic motivation. Engagement is not just sitting quietly and listening. It's when students are trying, asking questions, discussing, making things, testing ideas. In other words, active doing, not passive listening. Intrinsic motivation means students do something because they find it interesting, meaningful, or satisfying, not just for grades or external rewards. This matters because intrinsically motivated students persist longer when it's hard, take more initiative, and ultimately learn more deeply. Albert Einstein once said, "It's not that I'm so smart, it's just that I stay with problems longer." Our goal is to help students stay with problems longer, and AI, when used well, can support that. So, what breaks engagement? In many of our classrooms, students disengage when the work is too hard. They hit a wall and there's no timely support. Confusion turns into frustration and then into, I'm not good at this. The work is too easy. They get bored. They feel like they are just going through the motions. Feedback is too slow. They submit a tutorial or assignment and get feedback days or weeks later. By then, the emotional connection to that effort is gone. One pace for all. We often teach at one pace, but some students are lost, some are coasting, very few are exactly at the sweet spot of challenge. On top of that, we have structural constraints, large class sizes, limited time for one-on-one help, limited resources for human tutoring. The result is an engagement gap. Students' time in class does not always translate into active, motivated learning. This is where AI tools, especially AI tutors and chat-based systems, can help. Across multiple studies, a consistent pattern appears. Instant hints and checks. Students make more attempts per class. AI can adjust difficulty and examples to the learner, not just the syllabus. AI can provide timely, specific feedback where humans can't scale. It's important to be realistic. AI is not a magic cure. The quality of the tasks, our pedagogy, and ethical guardrails still matter a lot. But when integrated thoughtfully, AI can strengthen the feedback loop. Try, get feedback, adjust, try again, and that loop is at the heart of genuine learning and motivation. Let me briefly walk through several research-based cases that inform how we should think about AI in education. What changed? Students in the AI-supported group attempted more questions, received instant tailored feedback, and showed significant score gains compared to students without an AI tutor. The key drivers were not fancy graphics or magic algorithms, but fast feedback and right-sized tasks, neither too hard nor too easy. In settings where there simply aren't enough high-quality human tutors, AI can be a low-cost way to close part of that gap. Case 2, AI tutoring versus in-class active learning. Another randomized trial compared AI tutoring with in-class active learning. Findings included students using AI tutors achieve higher post-test scores with less time on task. Motivation increased, but enjoyment did not necessarily change. Learning got more efficient, not necessarily more fun in a superficial sense. Where humans were absent or feedback was slow, AI gave large benefits. When the comparison was a good human tutor, AI's advantage shrank or disappeared, which is actually encouraging. Good teaching still matters. Case 3, systematic review of AI intelligent tutoring systems. A major review across thousands of students found that AI-driven tutoring systems consistently improved learning outcomes, particularly when class size was large or feedback from teachers was slow or limited. So we see a pattern. AI is especially powerful where personalized feedback is scarce. Case 4, how students say they use AI. In another study, students reported the impact of AI on their learning. 88% said their efficiency improved, 64% reported more initiative, 59% felt their creativity improved, around half felt their independent thinking improved, with a minority reporting it went down. Interestingly, many students still worried about accuracy and knew they needed to double-check AI outputs. This tells us students can feel more confident and autonomous with AI, but they also need guidance on verification and critical thinking. Another line of research shows that high quality, timely feedback does more than just improve scores. It can actually strengthen intrinsic motivation. Here's the chain: clear, specific hints and explanations. Students feel more competent, they are more willing to try, they persist longer, and learning outcomes improve. So quality of help, competence, willingness to try, better outcomes. AI can give that help at scale if we design prompts, tasks, and guardrails well. So what does this mean in practice? For teachers, AI can take over some of the routine explanation and checking so that we can spend more time on designing rich tasks, facilitating discussions, coaching higher order thinking, connecting content to real-world contexts. For students, AI can speed up feedback, offer multiple explanations, allow them to practice at their own pace, reduce the fear of asking a stupid question. The goal is not shortcuts, but smarter practice. For parents, AI tools can give insight into progress without constantly watching or pressuring the child, and without exposing too much personal data if chosen carefully. In short, AI used well augments the feedback and motivation loops that already drive learning. Of course, there are serious risks if we use AI badly. Studies with pre-service mathematics teachers, for example, highlight 3 issues. Over-reliance. When students lean on AI for every step, they develop weaker mental models. They may get correct answers, but they don't internalize the concepts. Shallow copy editing. Students sometimes use AI merely to polish text, fix grammar, rephrase sentences without real reflection. The work looks good, but the thinking doesn't deepen. Reduced peer interaction. Instead of asking classmates or forming study groups, some students just ask the AI. This can weaken collaboration and social learning, which are critical 21st century skills. So there seem to be 2 main paths in how students use AI. A learning-oriented path: brainstorm ideas, clarify confusing parts, outline or revise drafts thoughtfully, check understanding and ask why, not just what. A shortcut path: generate text and submit it with minimal changes, skip reading the original materials, avoid grappling with sources, let the AI think instead of thinking for themselves. Our job is to design our teaching so that students are nudged strongly toward the learning-oriented path. We also can't ignore the ethical side. Risk to critical thinking. If students always ask AI, what should I think, instead of, can you challenge my thinking? Critical thinking will decline. Inaccuracy and bias. AI can be wrong and sometimes confidently wrong. It can also reflect and amplify biases from its training data, data privacy. We need to be careful what student data is shared, how it is stored, and whether tools comply with local laws and institutional policies. So part of our task is to teach students to be critical users of AI, not passive consumers.
Given all of this, what is the teacher's evolving role? 3 key shifts.
Mastering prompt design. We need a working literacy in prompt engineering, not as a buzzword, but as the skill of asking clear questions, giving context, specifying format and constraints, and asking for explanations, not just answers, designing assignments that reward learning-oriented use. For example, ask students to show their thinking process, not just final answers, require personal reflection, connections to class discussions or real-world examples. Ask them to critique or compare AI outputs with their own reasoning. Teaching students to critique AI outputs. We can explicitly train students to check sources, look for inconsistencies, ask what assumptions is this answer making, and verify key claims.
In other words, teachers become orchestrators of human-AI collaboration, not replaced by AI but repositioned.
Let me suggest a few practical strategies you can test in your own classes. Instead of letting students paste a question and get a full solution, we can structure activities like ask the AI to give you only hints and questions, not full solutions. Students work step by step. They attempt the problem. They ask the AI for a small hint. The AI asks, what have you tried, or which formula might apply here? Only after showing their work can they ask for a worked solution. And even then, they must compare it with their own. This keeps students in the productive struggle zone, with AI as a coach, not an answer vending machine. Strategy 2, prompt plus verify. We can teach students a simple cycle: engineer a good prompt, provide context, goals, and constraints. Check clarity and depth. Does the answer match the question? Verify critical claims. Check with textbooks or reliable websites. Test with small examples. Refine the prompt. Ask the AI to be more precise. Show each step, or explain why option B is wrong, not just why A is right. When output quality goes up, motivation and outcomes tend to follow. Strategy 3, use AI as a mirror, not an oracle. Use AI to reflect and refine your thinking, not to replace it. Students can first write their own solution, explanation, or essay outline. Then ask the AI, please critique my reasoning. What assumptions am I making? Give me a counter-argument to my conclusion. Where might this be wrong? This way, AI becomes a mirror that reveals blind spots rather than an oracle that tells them what to think. We can also ask students to grade their own thinking. They submit their work, ask the AI for a rubric-based critique, then reflect, do I agree with this? Why or why not? This keeps human judgment in the loop and builds metacognition, awareness of one's own thinking. Let me close by coming back to our main theme. AI in education is not a magic cure. It will not automatically fix disengagement. It will not automatically make students love STEM. It will not automatically produce deep understanding. However, it can be a very powerful catalyst. It can help us personalize practice and feedback at a scale we could never manage alone. It can support students in their zone of proximal development, that stretch but doable space where the best learning happens. It can strengthen autonomy, competence, and relatedness when used thoughtfully, thereby boosting intrinsic motivation. If we design our tasks and guardrails well, we can create a virtuous cycle. Motivated students dig deeper, dig halfway, achieve more, find learning more rewarding, become even more motivated. But this works only if we guide students away from the shortcut mindset. Let AI think for me, and toward the growth mindset. Let AI help me think better. That is our challenge, and also our opportunity as educators in the age of AI. Thank you very much for your attention. I'd be happy to discuss questions or hear your experiences with AI in your own classrooms.